So this is question 3. A solid cylinder 1 meter in diameter is used as an automated gate valve. So you can see the picture here. So in this arrangement, this is the cylinder. This is the free surface. So here is water. You can see the height here is, and in this case, you see here the material is air. So it is designed to find by pivoting about the hinge A. So this is the point A where the water level has exceeds 4.5 meter. We need to determine the mass per unit length. So the thing is, keep in mind per unit length. So per unit length means L, it will be equal to 1. So we will calculate the mass. Okay, so let's start with the calculations. So at first let me draw this figure. So this is the cylinder. You can see this is the cylinder. So it was A. So this is D because I actually created some imaginary section for this case. You can see this is the height is 4.5 and this is the pre-surface. So let me show this on here. So this is this free surface, the water surface, and the height from this pivot point A. You see this distance is 0.5 meter. So the whole distance is 4.5 meter. And if this distance it is only 0.5 meters, so we can say this distance is 4 meter, right? This is simple. And you see this is actually the cylinder, and if we consider this is the pivot point, and if we consider this space, you see this is actually a curved surface. So far we solved two problems for curved surface, and when it is curved surface, you know, the force direction actually changes, and we know force usually works to the, you know, always to the normal directions, and that's why when it is the horizontal, you know, the curved surface, we usually use or calculate two different forces like the horizontal force and the vertical force. So you already know that. So this is the F phase, this is FV, the vertical force, and we will create some imaginary section like A, B, C, D, this zone. So the vertical force is acting this way. You see these directions. So this is the vertical force directions, and you know vertical force is usually the weight. So now if this distance is 0.5, so we'll explain that on later maybe. So this is 4. So actually this is the center of the circle, right? And it is hinged at the point D. So this distance is 0.5. So this is actually this distance, this is actually all the radius. So this radius, it is also 0.5, and from this point to this point it is actually the diameter, right? So we can say, okay, this is also 0.5. If it is 0.5, then this is also 0.5. Now if I say calculate the area of this imaginary section, so then you can see that if we want to calculate, so look here, this is actually the area. We're calculating the area at the very beginning, right? So this A bar or A prime, this is A dash. So this is the area. So if you see here, we got a rectangle. You see this is a rectangle, this part, and this is a quarter circle. So like this, look here, this is the quarter circle. So if we calculate the area for this whole domain, then I can say, okay, the area of this rectangle plus the area of the quarter circle. So we know how to calculate the area of the rectangle. That means it should be this length and this width. So what is the length? It is actually the 4 meter. That means 4.5 minus 5. You see, 4.5 minus 5 into this distance 5. So this is actually the area of the rectangle. And when it is the quarter circle, If we say this is the whole circle, say this cross section. So this is the quarter that we're considering in this case. So in our first circle, this is actually pi r square, and this is the whole area of a whole circle. And when you're considering only the quarter, then it should be pi r square over 4. So it should say 1 over 4 pi r square. This 0.5, this is actually the radius, right? So if we simplify this equation, then we will get the overall the total area is 2.196 meter square. It is area, you can see this unit, so that is area. So now we will calculate the force, actually the horizontal force and the vertical force. So let's calculate the horizontal force at first. So the horizontal force of this cylinder, it always acts through the center of pressure, right? So how to calculate the horizontal force? You already know this is the rho g has. So rho is the density, gravity, and the height, and the corresponding area. So here you see this is the, and one thing I said earlier, the per unit length. So that means in this case L equal 1. Okay. So the density, this is the material is water 1000. The gravity, it is constant. And how we will get the area? The area is here, you see. Okay, before showing the area, this is actually the haze. So you see how we calculate the haze. So we always know that the horizontal force, it actually goes through the center of pressure, and we need to calculate the distance. It is actually the distance from the centroid. So from this point to this point, you see this distance, it is 0.5. So if we say that, if we consider the distance from the centroid, say it should be 0.5 over 2. So look here, this is 0.5 over 2. That means this is the centroid distance, and then we need to subtract from this whole distance 4.5. So this is 4.5 minus 0.5 by 2, right? So this is the height C. And if you are confused with this section, the area, we know area equal maybe the length and the weight. In this case, you see this AB, this is 0.5, and what is the length? We are calculating for per unit length, so that means it is actually into 1. So we will get this overall distance, it is 20.846. So you see here some side notes how to calculate the height C and the area in the vertically projected section. So we said, if you can see the side note here, for per unit length L equal 1. So we got the horizontal force. Now we will calculate the vertical force for this. Okay, so now the vertical force. So the vertical force on the cylinder, so definitely this is also for per unit length. So we know from the previous problem, the vertical force AB, this is actually the weight of the the corresponding liquid. So in this case, the vertical force is acting this way. So this is actually the directions, right? The vertical force is acting this way. So it should be the weight of the imaginary water volume. So this is actually the imaginary water volume. So this is shown in this section A, B, C, and D. So then how to calculate this vertical force? The formula is rho, G, and V, volume. Here we know the volume equal actually if it is 3D case, so that means the length, the height, and maybe the weight, right? So let's say just for proper understanding, so we say this is the length, height, and the weight. So that's the volume. So if you can remember, look here, we calculated the area, right? We calculated the area. So it is this height and this weight, and if we multiply the length with this area, then we'll get the volume. So see what I did. I said f dash into 1. What is 1? This is the length. This is the per unit length. So L equal 1. So then this A prime into 1, it should be the volume. So we got the volume, we know the gravity, and we know the density. So substitute all of these values. Simplify this by using a calculator. You will get the vertical force is 21.5 per 6 kilonewton. Now, once we have done with the horizontal force and the vertical force calculation, so that's we have done so many things. So for the curved surface, now let's calculate the resultant force. So you know the resultant force, this is F, and this is just the square root of F square plus FV square. So we know F is equal 20, we got it previously, and we know FV, we just got it from here, and if we simplify this, then it's like close to 30 kilonewton. So we got the overall resultant force, it is 30 kilonewton. So now we will calculate the angle, the corresponding angle. So tan theta, and we know the tan theta, this is actually equal to the vertical force or the horizontal force. And if we want to calculate the theta, then it should be tan inverse FV and FS. I believe all of you know actually this sort of calculations. So it's kind of, we need to multiply tan inverse in both sides. So here we will multiply tan inverse. We will multiply tan inverse in the right hand side as well. So then tan inverse and tan, it will just, we can eliminate, it will be theta, and the right hand side it should be tan inverse FV/FS. Okay. Then substitute the value of FV and FS, then we'll get this angle. So which means we got a resultant hydrostatic force which is 30 kilonewton. So it will act on the cylinder in the line of action, which will pass through the center of the cylinder. So it will go through the center of the cylinder and it will create a 45.95 degree angle with the horizontal directions, right? So what it means, a hydrostatic force of 30 kilonewton, okay, it will act through the center of the cylinder and it will create a 45.95 degree angle with horizontal directions. So now look at this figure here. Actually here what is going on, you say this is the pivot point D. Look at this center. So the horizon, it creates this angle theta. This is 45.95 degree angle. So this force, this is just going this way. This is actually the hydrostatic force, the resultant force. And we know this is actually the radius of this cylinder, and the weight, it is actually the acting in this way. So this is the weight, and definitely you see this W here, this is actually the weight of the cylinder per unit length. If we say here this is the point D, and you see it creates an angle theta here. So if it creates this angle, so definitely this angle, this is 90 degree. So this is the perpendicular body, right? And we know from the previous problem, if it creates an angle here, then it will be like f sine theta, and it's the horizontal as it will be the f cos theta, right? So we need to actually calculate the moment, because our ultimate target is we will calculate the mass. So taking the moment about this point D, how many the moment is working here? So the one is the major moment is the weight. So it is acting this way, and the the vertical distance, this is R. So this is W into R. So this is weight into the the distance. That means this is the radius. Now, so you see the another force, this is the resultant force, actually F sine theta. It is acting this way. So it should be minus here. It's going to the opposite directions. So F sine theta and the distance is R. So now, if we simplify, then if if we just eliminate this one, so you can write, okay, F W into R equal this, so you can eliminate this R and this R, so it will be W equal F sine theta. We know F equal 30, we know theta equal this. Then if we simplify this term here, then we'll get the weight. So now we got the weight is W equal 21.56 kilonewton. What was our target actually? If you can remember, initially we said actually we need to calculate the mass for per unit length, right? So we are going to calculate the mass for per unit length. And we know mass equal weight equal mass into gravity. So the gravity is constant. We know the weight. So then write mg equal 21.56. So if we simplify this, then we will see this is very simple. We get the mass 197.8. So that's actually the total procedure what I did. So as it was, a curved surface, initially we calculated the horizontal force, then the vertical force, then we calculated the resultant force, corresponding angle, and then we calculated the moment, and from the moment we got the weight, and we know weight equal W equal mg, so then we got the mass. So that's the question 3.